welcome to all people connecting in. Thank you very much for taking time out to share this webinar. I want to present first, of course, Eric Griffith, who has so kindly taken on to run this webinar. He is the Chief Operating Officer of Petrotechnical Data Systems Houston office. He's been with PDS for some 10 years, first in the Netherlands and the last 5 years here in the US, in Houston. He's worked on petrotechnical software, it seems, his whole life, certainly one of the most knowledgeable people we know. And since 2013, he's been exclusively focused on real-time drilling applications, and he's responsible for PDS's WITSML Studio technology. He holds a PhD in computer science from Delft University of Technology, specializing in scientific data visualization, and the BS and MS in computer science. So a very well-read young person indeed. A bit of housekeeping. We will have a question and answer at the end, and you will see the question and answer features at the bottom of your Zoom screen. The chat is open, but we are not looking at it. So if you have questions, please use the formal Q&A process of Zoom to do that. There will be a survey at the end. Please take a couple of seconds really just to answer the few questions we have. This helps us program more content in the future. We are recording this webinar, and it will be posted on our website in our library section under webinars and video. So without further ado, I'm going to hand over to Eric for a very interesting presentation. Eric, thank you.
Thanks, Phil. I'm going to turn off my video here in a second, just focus on the slides. But one other thing that Jana mentioned is that if you use the chat, that's not anonymous, but I think if you use the Q&A, then that's an anonymous way to ask questions. So I'm going to stop my video here just a second and get going with the presentation. Is the screen still visible okay, Phil?
Yes, absolutely. Okay,
great. So my name is Eric Griffith, and like Phil said, I'm with PDS, or Petrotechnical Data Systems. And I'm going to talk to you today about Energistics and digitalization and possibly moving beyond data integration. Just a brief background about PDS for those of you who may not be aware of it. We're focusing on crossing IT expertise and upstream E&P expertise. We've got offices in Houston and London, Aberdeen, The Hague, and Sofia in Bulgaria. And we've been around for about 25 years doing consulting and bespoke software development for oil companies and service companies. And currently we have a couple of brands that we're focusing on. We have our Ava products, Ava brand line that's focused on geological modeling and making that more efficient and easier and more effective. And I'm responsible for our WITSML Studio brand, where we're doing a couple of things. We're trying to integrate with existing technology to help people deliver their data as WITSML. We're helping people bring their drilling data in-house for analytics or other purposes using WITSML. And we're also providing some open source WITSML technology to the community. On to the meat of the presentation. So the agenda for today, we're going to talk through a couple of questions. We're going to briefly touch on what is digital transformation and digitalization. And we're going to talk about how we build the technology that enables digital transformation. We're going to talk a little bit about how standards can facilitate a successful and sustainable transformation, how Energistics can support organizations that have successfully digitally transformed. And that's kind of the main point that we're working towards here. But the objectives in kind of talking through these particular questions that we're going to go through is we're going to look at digitalization and how that relates to Energistics and the standards that it supports today, and try to understand where standards play a role in digitalization and digital transformation, and some of the surprising places where they don't. And really the goal of this presentation is not necessarily to provide answers, but to pose some questions about where could Energistics go, where could standards go to make digitalization and digital transformation a more sustainable and successful endeavor. And so there may be some future opportunities to get together, maybe at workshops or something similar, to try to talk through some of these things. So first question, what is digital transformation? So for my purposes today, I'm defining digitalization and digital transformation, where digitalization is innovative digital technology and digitized processes. So digitized processes is taking formerly analog data and making it digital. Classic example of that is scanning paper well logs, turning those into digital formats that can be used alongside logs measured today using more modern methods, or recorded using more modern methods. And digital transformation is the radical change that leverages digitalization. So digitalization is an enabler, and digital transformation is what organizations and companies do to help them take advantage of that and do new things. And it's a radical change that involves new people doing new things and new roles with new work sets, and new teams and new organizations. And the idea here is that the change that digital transformation brings is revolutionary and not evolutionary, with the major caveat that the goals of a digital transformation are going to be defined by existing organizations, and the people that carry the change out, at least in the initial stages, are going to be those existing people, possibly repurposed, possibly not. So the illustration that I have here is self-checkout scanner at a grocery store, which I think pretty much everyone is familiar with. But for me, that's an example of a digital transformation that the grocery industry has already gone through, where the self-checkout machine itself is kind of the digitalization. So it's digital technology and digitized processes. It's brought a weight sensor and some cash handling and automated payment acceptance with a new console that users interact with. And it's brought those together to enable new processes in the supermarket. But the digital transformation is that grocery stores have new floor layouts to accommodate these things. The people that operate or support these are new people. The staff that help customers use self-checkouts are doing different things than typical cashiers. There's probably an IT organization inside the supermarket chains that deploys and maintains and supports these. And there's many new processes that have had to be brought to bear to enable people to do their own, pay for their own groceries. So moving on. So in our industry and in other industries, digital transformation is typically a journey, and there are many different journeys out there that people go on. But some of the things that they're working towards to enable being able to do new things in their business, to do things more efficiently and so on, are building on top of either data science or automation or the combination of them. My current focus in the drilling industry, that's heavily leveraging both of them. For geological modeling and seismic interpretation, that may be a little bit more focused purely on the data science side. But you typically get these pyramid diagrams that kind of describe what people are trying to do to enable them to get kind of higher value applications. So on the data science side, you start with data acquisition, then you start building data engineering applications on top of it that let you manage that data and get it where it needs to go. And then you put governance processes on top of that keeps your data clean and ready for end use. And then finally, you get to focus on your actual higher value objectives, such as business reporting, BI reports, basic analytics with Spotfire and so on, and then building up towards kind of the holy grail, which is artificial intelligence, deep learning, machine learning, all the sorts of things that are going to let companies get more insight out of their data, improve their operations in ways that perhaps their current workforce would not be able to do alone. And on the automation side, you have a similar kind of journey where they're working towards machines that can do things more independently and intelligently, and can be driven from higher level processes rather than kind of low level steps. And in particular, in the energistics domain, there's a relationship or interrelation between these two pyramids where in the automation, you have machines at the bottom, then you have PLCs and DCSs that control those, and then you have higher level systems that let you see what's going on in those and steer them in an automated way, and then you get into kind of high-end applications. But it's this bridge between the low-level machine interface and the data acquisition that feeds your upward journey towards data science, where a bridge is being built to kind of facilitate the data generation all the way up to the high-value applications. A corresponding objective that a lot of organizations have, not focusing so much on the AI side, but focusing more on the analytics side and what they can do with their data, is the 4 or 5 types of analytics. And most people start with descriptive analytics, which is kind of looking backwards at, hey, something happened, why did it happen, or what happens, and then leveraging more data to be able to say, well, not only did I see a failure, but I saw, that before this failure, these other things went wrong, and that's probably what caused this particular failure to happen. And many organizations are taking advantage of that now, and where they're really interested in going as part of a digital transformation process is into the prescriptive and predictive analytics. So predictive is most often talked about in terms of predictive maintenance. So if I know that a particular part is approaching its end of life, I can go ahead and swap it out before there's a catastrophic failure in the middle of an operation. And prescriptive gets even beyond that. So there's 2 levels of that, but a prescriptive analytics says, not only do I think something is going to go wrong or something is going to happen, but here's what I think you should do in response for that. And that first level of decision support, there's still a human in the loop. So the analytics system surfaces recommendations to an operator. That operator makes a decision on the basis of that information. For example, should I shut the machine down for maintenance, or should I keep going? And decision automation is the next level, where the machine itself is intelligent enough to understand both what's about to happen, what steps it could take, and is able to go ahead and take a step on its own. So these are kind of typical objectives that people are working towards. And kind of tying it back to the original message, so digital transformation stands on the shoulders of the giants of digital technology and digitized processes. So to enable new organizations where, for example, you have data scientists that are supporting your drilling operations or are doing innovative processing on your subsurface data, they need to have both these digitized processes and digital technology to enable these next steps to take place. So the next focus in the presentation is going to be, okay, so we need digitized processes and digital technology, but how do we go about building those technology? We have to actually create it and put it in place. And for the rest of the presentation, I'm going to focus more on digital technology than on digitized processes, because that's my personal focus, and that's more where Energistics plays today. So the basic approach for creating this technology and enabling these changes in organizations is to invest in the foundation for these data pyramids, and then gradually build upwards from there. So these pyramids, again, are a very common illustration for how to increasingly get more value out of your processes or your data. So in this pyramid that I put together, highlighting where Energistics is currently focusing, which is in the WITSML arena, streamlining the acquisition of data and managing and getting access to good quality data. And this is the foundation of everything that sits above it. So no successful digitalization or digital transformation initiative can take place without good quality data. And this is a never-ending journey. You can't have good analytics, you can't have good analysis, you can't have good AI, you can't do anything without good quality data. So if you have bad data in, you're going to get bad results out of your higher level processes. And we're constantly trying to take advantage of new sources of data and use them in new ways and get at them faster with lower latency and from remote locations into central locations. So the acquisition process and that data quality management process is never going to go away. So we can't stop the focus on this base, but we can also extend our gaze upwards a little bit along this pyramid and look at sort of the next steps. So if you have a good enough foundation, then the next steps up from there are to provide standardized access to get at that data so that it's easier for people to come in and build applications that can consume that data and fuse data across different domains. And so then you start getting into frameworks that make it easier to piece together applications, or maybe let your data scientists build applications rather than having to hire a whole team of developers, or let your R&D folks experiment more rapidly with production data. But all of this is enabling you to build the high value applications that people really want to have. These are where you can start to deliver your new workflows, get your new insights, and enable the new ways of working. So if you can rapidly develop a new analytical tool or a new AI tool and deploy it and immediately get good quality business value out of it, that's when digital transformation really starts to pay back the dividends on the investment in it. So this is where everybody wants to be spending their effort, but it's important to not to forget that there's an ongoing investment needed here, and some increasing focus is needed here to let this happen faster and more reliably. So as organizations go through this process and start creating, in particular, these middle layers, the agile frameworks, the standardized access, and managing the quality of the data, there's some common themes throughout them. So people are trying to bring big data together. They're using data lakes. They're using computing in the cloud, or they're doing it at the edge. They're using IoT to get data from their sensors. They're using a lot of processes depending on where they are. If they're more on the manufacturing side, you'll hear a lot of talk about lean manufacturing, but you hear that also in the software side and in other areas. You got to be agile, you got to be responsive. All of these things let you move quickly and be nimble and agile and responsive to change, all of which are critical and what digital transformation is attempting to enable. And some techniques that people are applying, they're using data science, using deep learning, they're taking advantage of digital twins to understand what's happening in reality based on models and data. They're using, of course, data analytics, they're automating and mechanizing processes, they're using microservices architectures to help things scale out and be more dynamic and robust and easily replaceable. And beyond just, computing technology, they're also looking at things like blockchain or 3D printing to enable new ways of working. So 3D printing to be able to create custom parts in new and innovative ways that solve problems that couldn't previously be solved, or to reduce downtime and maintenance, and blockchain to leverage kind of trusted, shared views of information that don't require a third party to manage that. And people are taking these processes and these technologies and so on, and they're typically building what I'm calling this digital transformation computing model, where typically some part of this is running in the cloud, although in some cases it's still a data center. But this is really the common paradigm that any sort of production deployment of of a digitized or digitalized system that enables digital transformation looks like. You have some technology running in the cloud. You're getting some data into the cloud using message queues or APIs or direct connections to data stores. You've got some mechanism to move data between different applications and processes and data stores, which are either message queues or direct connections or some kind of orchestration service that's acting as a man in the middle to move it. Then you've got some kind of processing on the data, where you're doing either kind of stream processing or batch processing or event processing. You've got all kinds of data stores, from the traditional relational databases like SQL Server or Oracle to newer flavors like Azure's Azure SQL or Cosmos DB or Amazon's Redshift or Google's Bigtable or its NoSQL alternatives, and data lakes, which are in many cases are kind of glorified file systems hosted in the cloud. And then at the tail end of that, you've got some way to let end applications and users interact with the data that's been processed and stored in all these things. You've got message queues and APIs and direct connections. So you have all of this technology running in the cloud, interrelating to each other. And depending on whether you're dealing with big data, you may have a little bit less of kind of the movement of data between these things, or if you're dealing with streaming data, you may have a little bit more. So different applications will focus on different elements of this, but these aspects are pretty common across all kind of cloud computing technologies. And here's another big grab bag of technologies that people are building on to create these digitally transformed solutions. So again, you've got a whole host of these message queues and data stores, complex event processing frameworks and batch processing and stream processing frameworks. And these are just a small subset of what's out there. And these are all kind of IT cloud technologies that people are playing around with. And then there are folks in-house that are tasked with, driving digital transformation, are typically playing with business intelligence tools or machine learning and data science tools, trying to create these higher value applications and tying into all these IT applications. And then you have, in addition to that, the more traditional enterprise data tools that are the backbone and the workhorse of all these major enterprises, where you have master data management, and you have your ERP and customer relation management, HR, finance, logistics, data sources. All of these have the data that drive the day-to-day operations. And the advanced companies out there, the people that are thinking the farthest and the highest with digital transformation, are trying to bring these tools together with all of these. And in our particular domain of the upstream industry, we also have suites of subsurface tools or drilling tools and production tools, where end users are also trying to do their day-to-day work, and those also need to be incorporated into these digital technology, digital transformation solutions. So you have a whole host of technologies and tools that all need to interoperate together to enable digital transformation. But the problem that I think people are starting to face and come to grips with is there's really no standard way to exchange data across all these technologies. So each technology has a dedicated subset of technologies that they provide support for. And there's third-party tools that come in and provide connections, proprietary connections between different additional data sources. But still, there's between your two or your suite of technology, there's not necessarily a guaranteed way to get all of these to interoperate. And that presents a challenge. So we have both challenges in the interoperability and the representation of data. So we have people not knowing how to get their data into their preferred tools that their data scientists or their machine learning experts or their engineers are comfortable with. And even if they have an idea of how to get it into those tools, they don't necessarily know how they want to represent it. They don't know what data model they want to use, what the most efficient is, and what the most efficient storage mechanism is. So people are struggling with how to most efficiently move forward with these technologies. So the next thing we want to think about is, given we kind of know that people are on a digital transformation journey, they're trying to build technology that lets them be more efficient and get more value out of the data that they have access to, create new teams, work in new ways. They've got challenges in terms of what they, how they can best take advantage of cloud computing facilities or even just modern computing facilities to build these systems. So they've got a vision here of where they want to go. They've painted a picture like, hey, I'd like to get there. I want to get through this wall. So the question is, how can they successfully navigate this transformation rather than kind of getting burdened and hung up and not being able to achieve their dreams, their visions. So I want to turn this around a little bit and think about it more from the perspective of, let's imagine that an organization has successfully implemented its digital transformation strategy. So it's already operating in new ways, taking new advantage of its data. So what is it doing differently than organizations may be doing today? So its workflows are going to be data-centric. So everything, or many of the things that it's going to be doing, are going to be enabled by the data that it's pulling in from all over the place. It's subsurface data, it's drilling data, it's logistics data, it's HR data, it's finance data. All of that is going to enable these workflows. And it's going to be innovative. It's going to have clever people that are going to have access to the data, and they are going to come up with new ideas that haven't been thought of before. So they need to be able to get the data, access to the data when they need it and how they need it. And going back to the first one, they need to be able to trust that the data is there. Organizations need to be able to know that their data is secure and that it's consistent. And so that needs to be done efficiently without a lot of overhead. These transformed organizations need to not be afraid, or will not be afraid of change. So if somebody comes up with an idea that requires pulling cross-functional teams together to create new workflows that may result in changing processes internally or changing teams internally, that needs to be embraced. So the technology landscape that's being used needs to also be dynamic. So if you're using a particular cloud technology today and it proves to be inefficient for the next new thing that's already proving to have value, the organization needs to be able to quickly pivot and embrace the new technology without being burdened by people dragging it down with resistance to change or process getting in the way of change. And so data management is going to be central to these organizations. So they have to be able to manage all of this, be able to swap out technology. They need to be able to get data to the right people while still keeping it secure, high quality, and consistent and available. So that's got to be done efficiently, because this cannot be enabled by hiring gigantic data management teams. There needs to be new tools and processes to support these data managers. And I make the claim that data standards are going to be central to supporting these organizations, because without the ability to rely on standards, it's again going to be, for every technology and every data store that they want to use, they have to put in effort to be able to have that automated quality control and access control. And that's development overhead, that's training for people, that's additional staff with expertise in those data stores, and that's just not sustainable. So data standards are going to support these organizations by giving them robust, secure, low latency data transfer so they can quickly get at the data where they need it. It's going to give them domain appropriate data models so they don't have to reinvent the wheel and say, well, how am I going to represent this data when I put it in this new data store? It's going to give them standard interfaces so their applications can talk straight to the data. And if they need to swap things out to talk to new technology because that's more efficient or it works better, that's fine. Their applications don't necessarily need to change much because they're using standard interfaces. And it can also help with the data quality side of things. There can be data assurance best practices that are shared and standardized that allow people to not do their own bespoke solutions for managing the quality of the data. They can rely on standardized solutions for that. And in addition to that, standards are going to help them avoid the pain of dealing with competing data formats, getting locked into a particular vendor, and not being able to change as they when and how they need to. It's going to let them avoid some of the outdated exchange mechanisms that are popular today, like email or Excel. And it's going to also help them avoid poor quality solutions and unhappy users. So data standards today cover some of these, but it's likely that there needs to be an expanded scope to deliver some of the value that's going to be required by these successful organizations. So as an example, I'm going to talk through WITSML and how it's used today, and how some of these challenges or things are starting to be addressed using WITSML, but there's still some further opportunities for improvement. So this is a little bit of a thought exercise. So over here on the right, I have a lot of the things that people would like to do with their drilling data. So they're going to acquire the data at the rig. They're going to do some process automation on that data. They're going to aggregate it and persist it, typically at the rig site, and then also replicate that into the office. Many organizations have this current stack of applications that they're using in their real-time monitoring centers, where they're doing some alerting when things go wrong with the data. They're visualizing log plots of squiggly lines showing them what's going on. They're doing some mechanical specific energy calculations and figuring out what the rig is doing based on the data. They're doing some hydraulics and torque and drag modeling. And they're doing some calculations like, what are our connection times? What are our tripping rates? What's our drilling ROP? And that's kind of the standard suite right now. But what they like to be doing is, again, all of these prescriptive and predictive analytics. They'd like to be doing machine learning and deep learning and artificial intelligence. They'd like to have this data in their data warehouse so they can enable all these things. But currently with WITSML 1.4, there's not easy connections to these other technologies to enable that. So the next generation of standards are attempting to address some of these common areas. So WITSML 2 and the OPC-UA WITSML companion specification and ETP are trying to broaden the scope of what's supported kind of out of the box with the standards. So starts to bring in the ability to do data quality and transmit information about the quality of data, which is critical for enabling these higher value applications. It's strengthening the tie with data acquisition and hardware systems, and could eventually start to support some process automation. But it's still not yet actively tackling this upward movement of data into these higher value things. And it's not yet getting into the process automation space. So the question then becomes, in the drilling domain, what could be put in place that could help enable the data to flow more seamlessly to all of these applications? So these current applications are going to continue to be relevant, but there's other groups in these organizations that want to consume this data, that want to do these new things. So your performance monitoring group, your real-time monitoring group is going to continue to do these things, but your data science group and your data analytics and your R&D folks are going to want to do all these things. So we need to think about collectively as a community, how can we most effectively address this in a way that's sustainable? So, and I want to emphasize that notion of sustainable. So when you go to industry conferences and people talk about success stories, one of the most common things that happen is there's a particularly difficult audience member that will stand up and say, that's great that you have this success story. Are you still using this new technology? And the answer is invariably no. It turns out it didn't scale well to this new field, or, once we drilled a couple more wells, we realized that we didn't need this, it's too much overhead, or no, the operator's priorities shifted and they're not doing this anymore. But in order for a transformation to be sustainable, you can't have a team of people that are required on a dedicated basis to support and execute that. It needs to be something where your existing team, possibly only with minor additional resources, can roll out and support across your across your portfolio. It can't be a point solution. It has to be a universal solution. So again, going back to these technology islands, you can't solve these problems of getting data to all these other applications by building, point solutions that let you talk to one technology for this purpose. There needs to be some standardized approach to this that lets people easily take advantage of that from their current applications and data stores. So that's the segue to the next part of talking more about Energistics and digitalization and what role Energistics could be playing in digitalization going forward. So again, the reminder of the data pyramid I showed earlier. And again, the focus for Energistics is currently at the base of the pyramid. And I really want to emphasize that this focus is critical and it must remain. Again, this is the foundation upon which everything else is built. And without continued investment to support these new data sources, lower latency, higher quality access to the data, we can't continue to think about even newer ideas for higher level things. However, everybody has got challenges moving upwards. So people are trying to process large data in the cloud, and that's proving expensive and difficult. If you talk to somebody who's doing seismic processes about microservices, they're almost going to laugh at you and say that's almost an impossible thing to do. And I've talked briefly about it, but people are also struggling a lot with, hey, I've got all this data in these different databases in my company, and now I've been told I got to put it in the data lake, or I've got to do, my data science group has to get at it, or I've got to get it into Power BI. I don't know how to do that efficiently. So those are changes. And down here, the latency is going to continue to go down. People are going to need the data and the context to go along with the data. So these challenges are not necessarily currently being addressed and need to be addressed. And I argue that they should be addressed in a standardized way, because these are not necessarily things that are differentiating or proprietary. As an industry, we have a lot of knowledge about, and we spend a lot of energy defining data models and exchange mechanisms that let us efficiently deal with our seismic data, our models, our reservoir models, and our static models, our drilling data, our facilities data. And we need to bring that information to bear in these newer technologies so that we can continue to efficiently take advantage of those and, again, have a sustainable transformation. But even just beyond kind of these current focuses, the next level focuses for digital transformation are really starting to cross domains. And some organizations are already doing this and with some level of success. There's some great talks out there of people that have tried these things, but I would argue that it's still kind of isolated success stories and it's not sustainable practice yet. So things are, people are trying to integrate finance and engineering and logistics data. So doing things like adjusting your drilling program budget based on what's actually happening. If you're finding if a particular field is better than you expected, you may have to drill some more wells. And if you have to drill some more wells, you have to spend more money on drilling. That doesn't mean that you've exceeded your budget. And if somebody looks at your budget and says, well, you spent 10% more on drilling this year than you thought you were going to at the start of the year, but you're producing 20% more oil out of that field, that's not a failure, that's a success. So people need the tools to be able to do this more interactively and convey the right message. People can also get into things like, can you optimize activities based on equipment performance and local availability? Again, going back to the drilling example, you're drilling a well and you're starting, ROP is slowing down, you're not sure how much longer your bit is going to last. You might make a decision whether you're going to go ahead and pull a bit out or keep drilling ahead based on how quickly you can get a replacement bit there or a replacement tool that you're using for logging. If you know that it's going to take 5 days to get the next replacement part out to your well site, you may make a different decision than just purely looking at the performance data that your folks are seeing in the monitoring center. Another thing that people are excited about is the notion of smart contracts, where you're automatically issuing invoices when services are completed, or automatically monitoring the performance of the delivery of those services and adjusting the invoice payment accordingly. And that's still kind of within a single vertical. And you can get into these really blue sky workflows if you have really all the data in your organization at your fingertips, where you can do things like updating your reservoir simulation based on your actual formation tops while you're drilling. And you could even take that to the extreme of saying, well, based on our latest, this was a borderline field, and based on our updated results, we need to pull the plug on this, and we need to come back later because it's not going to be profitable enough for us right now. And we can do that without investing any further activity. We don't have to finish the drilling program before we make the decision that it was a mistake to drill that field. You might also interactively update your production forecast based on your geology as you're drilling or you're doing some other operation. You might also, if you have a dynamic understanding of your geology that improves your geosteering capability, you might even go in there and replan your injector well locations based on your revised simulation results to update things, so that you can really have a live view of the economic success of your current projects as the data tells you what's actually happening in those, as the uncertainty is pulled out by reality. So these are things that are kind of blue sky workflows that require this uniform access to data, both in traditional systems like your seismic data stores, your systems of record for your static models, reservoir models, your drilling data, but again, also getting into your finance and logistics data, your HR data, to bring all that together. So kind of thinking about, and just to close out this topic, so these are things that people are starting to think about. And when you start crossing sort of data domains at this scale, really I don't think anybody out there has put a lot of thought into how to do this efficiently or have a standardized mechanism to do that. So thinking beyond just kind of data integration challenges, which is the previous slide is touching on, there's other things that could benefit from standardization as we talk about this change journey, our digital transformation. So, operators are looking to enable these high-value workflows like data analytics, machine learning, and automation, and they're looking to roll out data quality best practices. How can Energistics make that easier for operators? Service companies are constantly optimizing workflows to make it easier for their folks at the field to configure their systems to meet the operator requirements. And they have a whole host of requirements depending on the operator that they have to meet. There's got to be some way that some of that can be optimized and standardized to reduce that burden. And there's also this notion that's borrowed from the automotive industry, where you operate on standards and you compete on sort of differentiation or technology and value add. So there's a lot of touch points between service companies and operators and equipment providers and software companies, where standards could suck a lot of costs out of the system and make everything flow a little bit more smoothly. And then service companies and equipment providers could redirect their energy into their value add, their automation, the unique insight that they bring because they see practices across operators and across locations. And that would let them refocus their energy on other places if they could rely on these standards. And kind of, again, the blue sky thoughts of, when we talk about best practices, there's classic examples like, if you're going to automate a dishwashing system, you don't build a robot that washes plates more or less by hand. You build a dishwasher. Are there similar things where the current setup of, the operator does this, the rig owner does that, or the acquisition company does this, and the service company does that? Is that the best split? Is there some kind of different way of a true best practice that could come in and, again, cut a lot of cost and time and energy out of processes if we could all agree on how to do it? And Energistics could also start to be a channel for getting more people involved in the decision-making process around standards and how to help this out. And I'll talk a little bit more about that on the next slide. So Energistics is the vehicle of choice right now for part of the industry, at least, with a focus right now on data modeling and data integration. So a lot of expertise has been associated with Energistics over the years and continues to be involved with Energistics that has a really deep understanding of the E&P industry, the types of challenges that we have with data that are somewhat unique to this industry. It's got participation from companies all across the industries, from service companies, equipment providers, operators, software, traditional software companies, kind of cloud software companies. So everybody that's kind of interested in how data moves and how to represent data in the oil and gas industry, there's participation from that group here. So Energistics is kind of the go-to place right now for bringing that expertise together and coordinating with the relevant parties and transforming that into standardized practices and data standards and data models. And looking at the broader industry right now and thinking back of Energistics' current focus really on kind of the data model and the data integration layer, there's a lot of value that Energistics could bring in taking advantage of the newer participants to Energistics like Microsoft and Amazon and Cloudera and HashMap and these more cloud-oriented technology companies that are actively enabling digital transformation, but don't always have the depth of experience in the domain that the rest of the Energistics community has. Bringing all those people together to focus on these problems could deliver real benefits to the industry. And it could do it in a way that's efficient, but it's important to understand that this would be potentially a new activity in addition to the current activity. Because again, Energistics is fully focused right now on this foundation of the data pyramid, and that work is not going to go away. So just taking the current participants that are active in those spaces and say, hey, you're now also thinking about digital transformation and optimizing the industry and defining new best practices will cause that investment in the base to suffer. So this is an opportunity for potential new collaboration and new focus in addition to the current focus. So this is the final slide of my presentation, and this is more of kind of setting the stage, hopefully for future discussion. But these are things that I want to share with you all and have you take away and think about, maybe discuss with your organizations, and maybe collectively together with Energistics at some point during this part of the year. But again, imagine we're in a world where digital transformation has succeeded. So how will operators and service companies and equipment providers and technology companies, independent software vendors and government and regulatory bodies, how will they all be using standards in that digitally transformed world? Because I argue that it will be more pervasive than it is now, but it will be in new ways that we haven't necessarily thought of. We have some ideas and we're moving towards some of them, but some of them still need to be thought through and some steps need to be taken towards putting those in place. And similarly, from cloud technology and drilling automation and finance and HR and logistics, many of these efforts or data stores and technologies that support these things are being used in digital transformation efforts, but they don't always have, in many cases, they don't have really a notion of a data model or a data access mechanism or data integration with E&P data. So, if you want to pull in data from your finance system together with your real-time drilling calculation system, there's no good way to do that right now, and certainly not vice versa, having your finance system be aware of drilling performance information. So could there be a role for E&P standards there? And could Energistics be the way to bring that knowledge to bear in that area? And thinking more about the role that Energistics plays, how could more of the industry be involved in defining the standards? There's a kind of a core group of participants right now, but it really kind of varies over time. And there's a lot of people that are kind of consumers of the standards. And then they think, well, it doesn't quite meet my needs today. But if they were more active, they could help ensure that it meets their needs. And particularly when they're focused on this next level of, I'm not so focused, for example, on getting my data from rig to shore. I pay for somebody to deal with that, but I've got to get my data science guys working with this data. How can we get them more involved and realizing that standards can help that aspect of their life be easier and more efficient? And to that end, how can we improve the development of the standards themselves, get earlier feedback, get more feedback, make sure it's more fit for purpose? And similarly, how do we make it easier for people to adopt and implement the standards that have been defined? So those are the questions that I wanted to pose. And just to kind of briefly recap, we talked about digital transformation and what people are doing and how they're trying to do it. And I tried to shed some light on how Energistics is enabling a subset of what people are trying to do today. But to really bring the data forward into the next steps, people are currently left to their own devices. So how can we work towards that and kind of make it easier for everyone together? So with that, Phil and Jenna, I think I'll turn it over to you if there's questions or anything.
Thank you so much, Eric. Really a galvanizing talk and a lot of interesting questions and also a lot of background information provided there. So again, thanks for taking the time out to prepare all that and share it with our audience.
My pleasure.
The Q&A is now open. So far, we do not have any questions posted there. If people have any inquiries to Eric or to Jana or myself about this presentation, please feel free to type in. Again, you'll find that little widget at the bottom of the Zoom screen. It normally is hidden, but if you bring your mouse towards the bottom edge, it'll pop up together with other options. To remind you again of what Jana said earlier, this presentation was recorded and it will be posted on our website within a couple of days. And we'll send out a notification to that effect.
I see a couple of questions popping up.
Just comments for now. Well, while we're waiting for an actual question, I would like to reinforce what Eric just said. Standards are as good as the number of people who take part in defining them. We encourage companies who are currently following but not actively participating in the process of defining standards to join the consortium. There's a lot of value in sitting in the meetings and hearing your peers in the industry discussing what comes next and strategizing how data exchange standards can add value to your business. I know that a lot of companies struggle with budgets, but the cost of joining this consortium is really pays back tenfold in terms of the insights you gain about all things digital. So we have a question. Do you have a demo of end-to-end WITSML implementation?
So there's not a standard demo available through Energistics, but I think the hope is in the upcoming WITSML iLab that there's going to be at least some integration, demonstration, and testing using ETP in the new WITSML 2.0 from a couple of different vendors.
To people who are not too familiar with the organization, an iLab is an interactive laboratory where members of a special interest group come together and run their implementations of one of the standard that's part of that particular group. And that gives them an excellent opportunity to iron out any issues or misunderstandings they might have had in their implementations. It's a huge value and accelerates tremendously the finalization of servers and clients and other parts of the chain.
with respect to the question about examples, if you go to our website under the resources, you'll see that there are some case studies where companies talk about their experiences implementing the standards. So that might be a place to start.
An interesting question about innovation. If you'll allow me, Eric, I'll pick up on that one. How does a vision for standards relate to innovation? Innovation happens across the whole demographic of our industry. Large companies, of course, but also small startups. If a startup has to actually deploy an innovation in a non-standard environment, there's a huge amount of time that has to be spent connecting that particular innovation to existing workflows, platforms, systems. The more standardized the environment is, the easier it is for a small company, pardon me, to introduce innovation and leverage it across the whole spectrum of customers and partners. So innovation is very much a relevant topic around standards.
And I'll just add a little bit there. So I think, again, yeah, just to emphasize what Phil said, so innovation is about, the ability to change rapidly. So there's some inherent kind of tension with standards there. But what I think is really missing right now is almost everybody is trying to use these cloud technologies that I mentioned before, of, data stores and message queues and all that sort of stuff to exchange data to enable this. And I think that is mature enough at this point to be able to define some standard ways to access large E&P data like seismic or reservoir models, or to exchange drilling data, including the metadata and the context around that. So I think there's space there to streamline that so that you can change your technology choices even faster than you can right now. Because right now, if you pick, say, a particular cloud technology in a particular cloud database, you're kind of stuck with that for a while. So that actually limits your ability to innovate to some extent. So if you could have a little bit more freedom of choice and pull in more types of systems more easily, you could do a little bit more.
There's a question about Hello World. Eric, do you have any comment on that?
I think that goes a little bit back to what Jenna was saying. I think different companies out there have their own examples of how that works. There's a pretty standard workflow right now, although the way that it's implemented is different for different companies, where somebody at the rig site plays the role of the aggregator and centralizes the data in a corporate data store, and then somebody accesses that and monitors that. But there's many different variations of that depending on who's involved and what the objectives are. So the WITSML documentation has just very high level kind of straw man diagrams of this, but that's something that could be valuable to provide to the community. Kind of, here's an example of the types of things that are commonly done today.
Okay, thank you, Eric, for that. Okay, well, I think we've come to the end anyways of the hour we had allocated to this. We know that everyone has a busy day, and for some of the people looking in to this webinar, that it's actually pretty late in the night. So thank you again, everyone, for attending this webinar. Thank you, Eric, so much for all the work you put into making this happen. Our next webinars are already on our calendar on the website and will be focused around ProdML and DAS. So we encourage you to look at the program and join us in a month from now for the first of those webinars. As mentioned earlier, this has been recorded and will be on our website too. So without further ado, Eric, thank you again. Thank you everyone for attending, and we hope to see you soon in a future webinar.